So let's start with the basic topology. This is a topology that we will do is, and so let us go ahead and deploy it. This is 192.168. All the networks are 192.168, 1 dot something, 192.168. So major network you can say is this one, 192.168. Everywhere 192.168 I will use. So let us go and deploy this one. So the configuration of router 1 is interface gigabit 0/0 IP address 192.168.1.1 255.255.255.0. No, shut it down. Interface gigabit 0/1 IP address 192.168.2.1 255.255.255.0. No, shut it down. And what we require is we require a routing protocol, because before you have to stop the access, you should be able to access. So what we will do is we will say router EIGRP1, no automatic summarization, and network 192.168.1.0. But instead of saying network, if I want to be lazy, I can say 0.0.0.0 also. It will just work fine. What will this do? 0.0.0.0 will add all the interfaces inside OSPF. Let us go ahead and copy paste this one. Let's say copy. So this is the configuration of router 1. Let's say here, as of now, I am not doing any configuration related to access control list. So we will do it in 2 minutes. Paste the configuration and good to go. Copy, run, start. Best practice to save our practical. So this router's config is done. Let us assign these two PCs. Let's say desktop 192.168.1.2, gateways 192.168.1.1. In here, desktop IP config 192.168.1.3, 192.168.1.1. Let us write the configuration of our router 2. Enable config T router 2 gigabit 0/1 has 2.1, sorry 2.2, 2.2 gigabit 0/0 has the IP address of 3.1, and interface gigabit 0/2 has 0/1 is over here. So 0/1 has this IP address 2.2, 0/0 is this one with 3.1, and 0/2 will have an IP address of 4.1. And I'll say no shutdown to this one. Same configuration, router EIGRP, no auto summary, and network 0000. So let us copy and paste this configuration on router 3, router 2. I think I did not change the host name. Let us see. Yeah, host name is correct. Copy, run, start. Saving our configuration. This is the configuration of router 2. So I gave the IP addresses over here. 1, 2, 3, 4, 5, 6, 7. I'll assign it over here. Let's go on this one and let's ping, or let's give it an IP address 3.2 192.168.3.1, and let's assign an IP address on this one. What will be the configuration of your router 3? Gigabit 0/, this host name is router 3. Gigabit 0/1 has an IP address of 4.2. Gigabit 00 is 5.1, and no gigabit 0/0. Router EIGRP 1. So basic configuration of router 3 also. So I'll just go in there and paste the configuration. So let us say copy, run, start. Now what should happen is this guy in here should be able to ping. Let us go in here. Let us assign the IP addresses over here. 192.168.5.2, 192.168.5.1, and this is 5.100. 192.168.5.100, 192.168.5.1. Now first we have established our connectivity. Let us check this person 1.2 IP config ping 192.168.3.2. Is he reachable for 3.2? Let's see. So the reply comes means we have the connectivity. Now let us create a scenario and let us say that your router 1, what is the question, what is the question says? Your question says that the host on 192.168.1.0 subnet or the host 1.2 must not be able to connect to the host 192.168.3.2. Okay, so this is our question. And if we are using access control lists, how will we do that? For example, let us see a document. So these three are the important rules of your access control list. So create an access control list, the router will see it in a sequence, and then it will match. Once the match is once the statement is matching, action is taken, and by default everybody else is denied. These are the numbers for access control list. There can be two types of access control list. One type is a standard access control list and one is the extended access control list. There is also a named access control list, but it will be either standard or extended. So it is kind of same, EXTD. So what we will see is standard access list. So what is the role of your standard access list? See, first of all, if you want to create an access control list that is standard ACL, you need to specify any number between this range. So if you say access list number 1, your device automatically understands that you are trying to create a standard access list. If you want to create an extended access list, you will use a number between this range, or these are the expanded ranges. Now, what is the difference between your standard access control list and the extended access control list? Standard ACL just looks or just understands, just sees the source IP address, source IP or the source network, and second thing is it must be deployed near to the destination, means. Now how will you apply this access control list? So if I say what is the source is 192.168.1.2, where should I apply it? Near. See, how will you apply an access list? You have to create an access list on one router and you have to apply that access list on that router only. But where will you apply? You will apply on the interfaces. Now on the interfaces you have two directions. For example, if I say the data that comes in here, that comes on the router must be stopped. Just think as you are standing on this device over here. If you imagine yourself like we did in the Windows firewall, you are standing on the router and just imagine that the data is coming inside this interface. Should it be blocked while coming in, or should I block it while I send the data downstream? So now the question says, access control list says that 1.2 must not be able to communicate with 3.2. So the source is this. 1.2 is my source, 3.2 is the destination. Standard ACL must be created and deployed near to the destination. See, what will happen is if I stop the data while it comes inside this, it's okay, but the data is being dropped over here. The data is not sent over here. The data is not sent over here. What if there was an internet cloud over here? This guy was not even able to communicate with this guy or this guy also. But I don't want that. The requirement says he must not be able to reach 3.2. Rest all he should be able to send the data. So a standard ACL must be created near to the destination. Near to the destination means over here. How do you create an access list? So what we'll do is we will say on the global configuration mode, we will say access hyphen list, give it a number, access list 1. Now in an access list, there will be permit or deny statements. So access list 1, deny, I will say deny 192.168.1.2. See, I can say 1.0 and say, sorry, the host requirement. So 0.0.0.255, recalling the wildcard mask. 0.0.0.0 means you have to match exactly as it is. So if I say match 1.192.168 1.2, all these octets must be same. If I say 1.0 in here, and if I say 0.0.0.255 means I am denying the whole network over here. So the question says that 1.2 must not be able to connect. So 1.2 means I will say 1.2 in here and I will match all the octets. But instead of saying this, instead of getting us confused, we can say match deny the host. So access list 1 deny the host over here. Simple as it. This is the only one statement that you have to write. But there is a dangerous deny in here. So there must be at least one permit statement in the access control list. So we'll do that later on. But what we'll do is just for trial purposes, actually the syntax is access list 1 permit anybody else, anything else. This is the actual configuration of the ACL. But what I will do is I will not use this ACC. What I will do is I will not use this statement. Let's see what happens. Let's go in. See, if I give an exclamation, this statement will not be considered. So where will I put this? I will put it on router 2. First of all, this is able to ping. Yeah, this was able to ping him. Yeah, data was going properly. I will create an access list on router 2. In the global config mode, I will say access list 1 deny the host over here. Now, did I mention that permit any? Yeah, I mentioned it, but actually the statement was not taken because of an exclamation and the spelling is also wrong. Now, you create an access list. The second thing, there are always two parts to an access control list. One is the creation. Second is the application. So first job is what we did in here. We create an ACL. And second job is you have to apply an ACL. Now, the second thing is you have to apply this ACL. But where? Where will you apply? You will apply it on the interface. So let's go in here and let's say interface gigabit 0/1. I think, let's see. I will deploy it over here. So what will happen is the moment the data comes inside over here, this router will check whether there is an ACL. So this ACL will be compared on the packets that are going outside. So the packet will be matched. The packet says 1.2 should not go down and the packet will be dropped over here. So let's go back and let's do that. Let's write it. Let's say interface gigabit 0/0. Sorry, gigabit 0/0 access hyphen group. Access group. Okay, let's see, IP access group 1. What is this one? I am calling this ACL. Access group 1 out. Out is the outbound direction. I created an ACL and I told him to apply this ACL while the data goes down on the gigabit 0/0. But I did not permit anybody else. Let us see the effect. Let's go in here and let's see. Is it pinging now? The ping is happening, but we are receiving an ICMP echo back from 2.2. Who is replying 2.2? 2.2 is this guy over here. He says, I don't know about the third network. He says, I don't know this guy, but technically this guy has it directly connected. He says destination host is unreachable. So let's go in here. Let's ping from 5 dot something. IP config. This is my 5.2 ping 192.168.3.2. See this guy 4.1. This guy 4.1 over here. He says I don't know the destination. What I did was I did not permit anybody else. I have to permit anybody else. That is the reason it says you must have at least one permit statement in an access list. If you deny anybody, it's okay, but you should permit everybody else also. So what I'll do is I'll simply copy paste this configuration and I'll put it on your router 2. So let's go on the gigabit 0/ no, not gigabit access dash list 1 permit any. So before applying show access list, will tell us that there is only one statement. So if you are troubleshooting, you have to see show access list. It will tell you that there is one standard ACL, the number is 1, this is the sequence number, and the sequence number 10 says deny this one host, and there are 4 matches, means this guy tried to access that network. Now what I'll do is I'll put the permit statement over here. Show access list will tell me now that the first statement is denying and the second statement is permitting. So it's okay. All the other packets will match this second statement and all the others will be permitted. So let us see, 1.2 was denied, 5.2 was by mistakenly denied. So let's go in here and let's check. Now the data is being transmitted. See, previously it was destination host unreachable, but now the data is successfully reaching over there. So this is how you create a standard access control list, and this is how you deploy it over there. The thing about ACL is you can have only one access control list, one ACL per interface, per protocol means your IP, IPX or XPX. So whatever the protocols may be, IP, IPX, and in one direction, per direction, that is to be considered, because you cannot have one ACL that says deny IP but permit IPX. No, Macintosh, no. One access list can be applied on one interface. No, actually on one interface, per protocol, per direction. You can have multiple access lists created on a router, but you can only use one on one router.